Matthew.
You'll never guess what I heard today.
What did you hear today?
The reason that math is banned is hidden on a government iPad.
Do you mean this iPad?
How did you get a hold of that?
I swiped it off my boss's desk this morning. I heard him talking about how this has like all the secrets to the government like recently updated on it. It's the new iPad. I thought we needed this to get to the bottom of why math is banned.
Well, that's convenient. Let's get cracking.
All right.
Oh, password protected, huh?
Yeah, what do you think it could be? 42?
Worth a shot?
42 is always the answer to everything. Well, except this, obviously.
Try 1999. Everyone loves a good 1999 Ford Ranger.
So true.
No luck here as well.
Well, what do you think these are?
I don't know, but they've got to have something.
I mean, I've been reading a lot of economics lately, and they look like economics math problems.
That can't be. Math's been banned for so long.
Do you have any other ideas?
Not this time.
Well, I think we should try it.
Hey, can I bite of your donut?
That's not important right now. Let's get to it.
Oh, sorry. Can you figure these out? I'm really out of practice. I haven't done math since the incident.
So actually, like when I went to Harvard a few years ago, I had this professor named Dr. Leontief, and he developed this system of equations that had 500 equations and 500 variables that using linear algebra to make an economy better, he reduced those 500 variables down to 42.
That's impressive and sounds like something we should work on. Do you think you could do it?
I think I could probably try. So let's start with writing out the given matrix, okay?
Sure.
So first we've got the 1999 Ford Ranger column. Okay, so let's go down from 1999, and then we'll go to fruit, fish, whatever, and gummy worms.
Sure.
Okay, we've got 0.1, 0.2, and 0. And then down, it goes the same way it does across. So we've got the 1999, the fruit. Well, I guess I should get that in line.
Probably important.
Probably. You know what Leontief always said? Make sure your matrix is in line.
Didn't know him personally, but I believe he'd say that.
Very characteristic. All right.
Sure. I think I've seen something like this before now. It's crazy how math is like riding a bike. You crash and burn a lot. Anyway, so each column represents the inputs required from the other parts of the economy to create one output for that column. So for example, fish takes 0.6 units from the Ford 1999 Rangers to produce one fish. It also takes 0.5 fruit, 0 fish, 0 Worcestershire sauce, and 1 gummy to produce one output of fish. So how many does it ask us for?
It asks us for 50.
I think we can isolate the column here to create a single vector.
Okay.
Where we include all of its parts. And we simply multiply by a scalar 50 to get the number of units, since this is what it takes input to create one output of the fish, which means we'll end up with Leontief ever say anything about trying to write your 5s correctly?
No, he was pretty good at that.
Oh, man. Meaning that the intermediate demand for 50 output of fish should be 30 Ford Rangers, 25 fruit, and 50 gummies without any additional fish or Worcestershire sauce necessary.
Do you think we should try putting that in as the password?
Oh, we can always give it a shot.
Okay, hold this. Okay. Do you think I should keep the zeros or not?
Yeah, I'd say they're important.
Okay, that's what I was thinking too. So we've got 30, 25, 0, 0, 50.
Man. Well,
all right, well, I
that
guess
was good practice. It got me back into things, but we should probably move to the next one.
there's just not a lot of room left on this board.
You're right. This is way too big.
We need to move on to something bigger.
There we go.
Perfect. Okay,
Well then,
on to problem number 2.
before we get into that, I'm feeling a bit hungry, and without that donut, I'm gonna need something. Well, I feel much better, and while I was gone, I did a bit of reading, and I wrote some things down that might help us.
What did you come up with?
Not all of that, but let's start with writing the problem.
All right. Find amount produce. Whoa, that was fast. I don't think I understand what you did here. Could you explain it to me?
Yeah, absolutely. So it was pretty fast, but I think it makes sense. We'll start by looking, we're asked the question, find the amount produced for a final demand of 20 1999 Ford Rangers and nothing else. So from that, we can establish our demand matrix, which is 20 with all zeros, so we're not going to have anything else. And then looking at the board over there that you provided us with some of the information from class, we found that the input-output model can be reorganized where it's I times x vector minus c times x vector equals d vector. But we can even reorganize that further towards I minus c, which are two matrices, times the x vector is equal to d. So we just fill in the information we had. So the identity matrix with 5 columns looks like this, and subtracting C, which we call the consumption matrix, which was given to us by the mysterious sticky notes on the iPad. And then we'll multiply it by our x vector, which is just the x for every item that we have. These in combination create our intermediate demand, and then we have our final demand vector. So we subtracted these and then augmented the final demand on to get what's here, and so these are the results with the demand at the end. All that's left is to solve, which brings us to this side. By taking this into reduced echelon form, we get the 5-column identity matrix, and then our results, which is the amount produced to create the final demand of 20. So to have 20 Ford Rangers at the end and nothing else, it would take 5.5 Ford Rangers, 8.5 fish, 14.9 fruit, 22.5 Worcestershire sauce bottles, and 22.5 worms.
Don't you think it's a little weird that it takes 22.2 bottles of Worcestershire sauce to make 20 1999 Ford Rangers?
Really weird.
Anyway, I think we should put this into the iPad.
Let's give it a shot. I bet if we just put the numbers all in order from top to bottom, it might be the password.
Okay, so let's do 5, 5, 8, 5, 1, 4, 9, 2, 2, 2, 2, 2, 5.
Damn. Well, we've only got one sticky note left. Let's get to it.
All right. And finally, we have negative 27.6. Okay.
So I understand that if we take the intermediate demand, which is defined by the matrix given to us, our consumption matrix, and multiply it by the amount that we're interested in producing and adding in the final demand, we'll get the total amount produced over the whole thing. I mean, that's what our input-output model tells us. I know that we can reorganize it in different ways to solve for the final demand to make that easier, or at least the what's necessary to get to a certain final demand, but I don't understand what we have here.
Well, let's read the problem. So, we need to find the amount produced for the final demand for 5 Ford Rangers, 10 fruit, 11 fish, 7 Worcestershire sauce, and 12 worms. Use the inverse matrix. I think that means Theorem 8, the invertible matrix theorem. So, first, we go ahead and start with this. X hat is equal to I minus C to the inverse of D, which we see here as a new reorganization of the original input-output model that we talked about earlier. So, what we do is we fill in what we know. We have X hat being this matrix here, which is equal to the inverse of I minus C, which is here, which is the identity matrix minus the consumption matrix, times D hat, which is the 5 Ford Rangers, the 10 fruit, the 11 fish, the 7 Worcestershire sauce, and 12 worms, okay? And since the determinant of I minus c is not equal to 0, it is invertible, letting us do this, which gets us to the final amount produced, which is negative 36.1 for 5 Ford Rangers, negative 8.6 for 10 fruit, negative 22.8 for 11 fish, negative 50.9 for 7 Worcestershire sauce, and negative 27.6 for 12 gummy worms.
So the negative means that we consume it, and it'll take this amount, just total produced in general, to come up with the final demand to consumers of 5, 10, 11, 7, and 12.
Yeah, does that make sense?
That makes sense to me, but the only mystery left is, what is the password?
I don't know. I think we should put it in, but I've got to go sit down.
I agree. Are you ready?
I'm ready.
All right, let's do this.
All right.
I'll read you the password.
Okay.
3, 6, 1, 8, 6, 2, 2, 8, 5, 0, 9, 2, 7, 6.
Okay.
This is it.
We're in. Okay. Biggest government secrets. Can you believe there's only 3?
Wonders how to say Worcestershire.
It's not important.
Sorry.
I feel like we're the only 2 mathematicians left in the world, and this might change that.
I think you're right.
Okay. Do not click. I think we have to.
It's the only way.